So in this video, we're going to practice and then walk through naming several different ionic compounds. So go ahead and pause and give these 6 a try, and then come on back for the walkthrough. All right, so if you're back, let's look at our first one. Well, Zn is zinc. And CO3, if you look at our polyatomic anions, is a carbonate. So we need to figure out some charges for it. Well, a carbonate, we know, comes with 2 negatives. That is the charge on our polyatomic anion carbonate. You just have to remember that from the list. A CO3 is a 2- anion. Well, that means I have 2 negatives. My zinc needs to have 2 positives to balance it out. And so this is a zinc 2 carbonate. If we jump over here to our vanadium containing molecule on the top right, well, V is vanadium. HCO3 is a bicarbonate. HCO3 is a 1-. It's basically carbonate with an H plus attached. So it gains the hydrogen and the plus cancels one of the minuses. So I have a bicarbonate. Well, the formula tells me I have 2 of them. So I have a total of 2 negatives. I need a total of 2 positives, and I have a single vanadium to put them on. So it must be 2+. So this is vanadium 2 bicarbonate. Jump down here to our titanium 3 bromide. Well, in this case, we're told the charge right away. If we look up titanium, it is Ti. And it's going to have a 3+ charge. A bromide is a bromine anion. So bromine is Br. We expect that would have a -1. The fluorine, chlorine, bromine, iodine, the column 1 in from the noble gases on the periodic table, those are all -1. Well, I need 3 negatives to balance my 3 positives. So I can add more bromines until I have 3 negatives, which means this is a Ti Br3. That is our formula for titanium 3 bromide. Ammonium sulfate. Now this one doesn't have a transition metal. I want us to try another one from our polyatomics. Ammonium is NH4 with a plus charge. A sulfate is an SO4 2-. So these are our ions, as stated by the name. I need 2 positives to balance my 2 negatives, which means I need another ammonium. So the formula here, I need NH4, but I need multiple of them. When you have a polyatomic, you have to use these parentheses. We saw that up here with bicarbonate. But the idea is I need multiple of what's in the parentheses. So I put the parentheses on and I label the 2 after it. This is most definitely not N2H8. That is some completely different thing. And it is also definitely not NH42. That looks like a lot of hydrogens. And while 42 is the answer to most things in the universe, not in this case. So I need those parentheses in order to tell that I need 2 of the ammoniums, and then my SO4. Now, since I only have a single SO4, I don't need parentheses on it. Should I have had some molecule that required multiple sulfates, then I would have put sulfate in parentheses with the number of sulfates after it. You don't have to do that for one of an ion. And so NH4 2SO4, ammonium sulfate. Jump over here, Fe2O3. Well, I've got some iron, and I've got some, well, O3, that's not a polyatomic, we know. That is 3 separate oxides. So O2-, O2-, O2-. I've got 6 negatives. I've got my irons. They're going to have our positives, and I need 6 positives. Well, there's only 2 irons to go on, so each iron must be 3 plus. So this is an iron 3 oxide. And our last one in the bottom right, cobalt 3 carbonate. Well, cobalt is CO, and we say it has a 3 plus charge, because that's what the parentheses tells us. Carbonate, CO, 3 with a 2 minus. And so I have a 3 plus and a 2 minus. I'm going to need multiple of both. Slide this down a little. I need some more negatives, but now I have too many negatives, so I need some more positives. Now I have too many positives, so I need some more negatives. 6 positives, 6 negatives, a 2-to-1 ratio. So this would be CO2, then in parentheses, CO3, 3. Important here, and why I focus on this one, watch those capitals and those lower cases. Cobalt is capital C lowercase o, and carbonate is capital C capital O with 3 oxygens. So cobalt, carbonate, has a lot of C's and O's and numbers, but it's important which ones are which size to help you differentiate them.